Hi, in today's experiment, we're going to be, this will be experiment number 6. We're going to be talking about laser polarization and refractive index measurement using Brewster's law. So for this experimental setup, I already have a setup, but let me go backwards because this setup is a little bit complicated, but let's follow along, right? So first we're going to take out our sample. So let me take everything apart so you can see how it looks like. So we're going to take the sample holder from our accessory pouch, and the sample holder consists of a sample, that's a piece of acrylic, and a sample holder. And the idea is we'll clip on the sample onto the sample holder with this clip. So right there. Now, which way do you clip? So you could see that there is a very faint line. Let's see if I could focus. You could see there's a very faint line right there where my fingernail is. And what you want to do is that's where that line indicates the rotational axes go through the center of the turntable. So what we're going to do is we're going to mount the reflective face there. The other way easier to see it is you have a pointer here, so you want to mount the sample on the side of the pointer, not the other way around. So you want to mount it like this. So pointer faces right, and you want to have the sample face right aligned to the rotational line there, and the pointer faces right. And then what we're going to do is we're going to put it in the turntable. And then when you turn on the laser, which in this case is already on, but if you haven't, turn it on right now. What you'll see is if you put a piece of paper on the side, you could see some reflection light off of the face of the sample. And you're going to see two spots. The first spot is the laser light hitting the front face of the sample, and then there's also the back face of the sample. Right, so the laser light could be reflective of the first face, the left face of the sample, and then also on the back, on the right, where my thumbnail is. So front and the back. And what we care about is the one on the front, right? And what we want to do is we want to be able to measure at what angle does the light disappear. So to do that, we need a little bit of help. So what we do is we put the rubber band and a few 4 cuvettes here. This just to create a resistive, the rubbery surface. So that way we could put the business card against the edge of the mirror. Sorry, against the edge of the box without the card folding off. And then we don't really need the photometer in this case, in this experiment, so we could just put it on the side. And what we'll do is we're going to prop up the card like so. So that way we have the business card is acting as a projection screen. And what we're going to do is we're going to help the laser polarization to be more pure by inserting a polarizer. And then notice the way we're going to insert it. We're not going to insert it this way. We're going to rotate it 90 degrees and have the polarizer faces horizontally like so. So this is the way we're going to insert the polarizer, right, like that. And let's put the screen back. So I'm trying to rotate it so you guys could see it. All right, so that's our experimental setup. And then what we're going to do is we're going to rotate this thing until about 50 degrees. So the first dot, the dot on the left of the first face, of reflection is about 50. And then what we're going to do is then we're going to rotate the laser body in the laser stand until it's the strongest. So you could see as I rotate it, it gets weaker. Let me turn off the studio light so you can see it better. And as I rotate it, you'll see the laser light is the strongest. So usually that means the light will be slightly vertical because that's the shape of the laser beam, right? So if you collimate your laser, that's what you'll see. So that's when we select a laser polarization to be the strongest. So in your textbook, there should be a good explanation of why you will choose one laser polarization versus the other, right? So as you then rotate the turntable, you could see at some point the first dot almost disappears and then shows back up again. You could see that. As I rotate it, the first dot is really bright, really, really dim, and then bright again, right? So that's your Brewster's angle. Now, if you do the same thing on the other polarization, so if I rotate the laser, then you could see that the laser light it's more or less about the same, right? So it doesn't do the diminishing, right? So this is the difference between, oh, by the way, if you're going to do it that way, you want to rotate the polarizer as well. So as you rotate the laser to the other side, you want to rotate the polarizer. And the reason we add the polarizer in front of the laser is to make the light more pure. So you could see right now my laser orientation and my polarizer orientation, it's aligned, and then you could see there's no such diminishing light. You could see as I scan through the entire angle, it's about the same strength. So I'm going to do it again. So I'm going to rotate the polarizer and then rotate the laser such that I get a nice vertical line. And as I scan through it, you could see the first reflection disappears. And then your goal is to measure what that angle is. And here is the Brewster angle, theta B, stands for Brewster. And your job is to figure out what the refractive index is for N2, right? Because this is your incident light and this is your reflected light. And notice that only one of the polarization gets reflected. The other one gets refracted and transmitted through the material. And 2, that will be your acrylic, and 1, that will be the air. And your job is to measure theta B, which is a Brewster angle, and figure out the refractive index of the acrylic. In other words, calculate N2. Right, so that's it for today's experiment. I'll see you on the next one.